Hello and welcome to the Math Studio. In this video, we're going to look at graphing 180-degree rotations. So just quickly, what this is a combination of both reflection in the x and the y-axis, done one after the other. So given y equals f of x, then y equals negative f of negative x rotates the original graph by 180 degrees, centered on the origin. So if we recall, putting the negative in front of the f, so negative f of x, that basically flips all the y values from positive to negative and negative to positive. So that's a reflection in the x-axis. F of negative x reflects the graph in the y-axis. So let's say, for example, we're starting off with a part of the graph in quadrant 1. Negative x will reflect quadrant 1 points into quadrant 2, and then negative f of negative x then will reflect those quadrant 2 points into quadrant 3. So you start off with quadrant 1, you end up in quadrant 3. Now what this means then in sort of practical terms, in terms of coordinates, is that the x and y coordinates of every point on the graph change sign. So any positive x values become negative. Okay, any negative x values become positive. Any positive y values become negative, and vice versa. So let's have a look at an example. So I've used this example in a previous video, and so let's just go through it quickly. If we let y equal x squared minus 3x plus 1. So what I've done is I've just put a little bracket there around the x, and we'll explain that shortly, what that means. Then y equals negative, sort of open sort of square brackets here, just to make it a bit easier to see, negative of bracket negative x all squared minus 3 outside of negative x plus 1, close bracket, rotates the original graph by 180 degrees about the origin. So you can see here, this negative here is the negative f of x. And in fact, the negative x here, wherever you see the x, you replace that with a negative x. That's the f of negative x going on there. Okay, so let's have a look at this example on the graphing calculator. All right, so hopefully this will work. So I've already entered in the original function there, so that's x squared minus 3x plus 1. So what we're going to do now, hopefully let's sort of create a bit more space there. Okay, and then we'll zoom in on the screen. Actually, hopefully it'll make it a bit easier there. Yep. So what we're going to do is we're going to then type in sort of the reflections in both the x and the y-axis. So and that's going to be, now where I've got x squared, it's going to be negative x all squared. So negative x all squared. Okay, minus 3 outside of negative x. Okay, plus 1 and close bracket. Okay, so let's draw that and let's see what's going on there. So we can see the blue parabola there, and I'll zoom it out a little bit. Okay, and let's see what's going on there. Yep, so we can see the blue parabola there is our original parabola, and the red sort of concave down, so what was concave up now has become concave down, is our rotated parabola. So you can see that what's happened is that the blue parabola, let me zoom it out a little bit more, the blue parabola, the original parabola, has been reflected sort of from, well, in the y-axis, but then it's been reflected in the x-axis as well. So I'll just zoom it out one more time. Yep, and we can see there that there's been a rotation of 180 degrees. In fact, if I turn the calculator upside down, you can see that, in fact, it looks like the shape is still the same, except the color's changed, obviously. So, and that's our rotation in around the origin. Thank you for watching.